Hello, ladies and gentlemen. Today is 1.3 computations of involving function notation. So this lesson is a very important lesson because it introduces the idea of function notation, which we're going to see the rest of this course. So as we start here in our notes, it says the function f of x is read as f of x. F of x is a notation of a function that actually represents the y value. Okay. In other words, y equals f of x. Let's consider the function f of x equaling negative 2 times x plus 3 squared plus 4. Find each of the following function values. Okay. So when we look at functions, we have to remember that this whole thing right here represents our output. This is our output, which is the y value. Okay. And the value inside is called our input. In this case, the x value. Okay. So when we evaluate f of negative 4, we're plugging a negative 4 wherever we see an x value in the function. So this is f of negative 4 is equal to negative 2 times negative 4 plus 3 squared plus 4. Okay, so you'll notice that I just put a negative 4 to replace the x. The next thing I'm going to do is I'm going to solve inside the parentheses. I'm going to use order of operations. So this is negative 2 times negative 1 squared plus 4. And this is going to give us negative 2 times positive 1 plus 4, which then comes out to 4 minus 2 is 2. So we know that f of negative 4 is equal to 2. Okay, now let's do it again with negative 1 now, replacing x with a negative 1. So we're doing negative times negative 1 plus 3 squared plus 4. We're going to solve. This gives us negative 2 times 2 squared plus 4. And so we have negative 2 times 4 plus 4, negative 8 plus 4 equals negative 4. So f of negative 1 is equal to negative 4. Okay, again with 0, we have f of 0. Plug a 0 wherever we see an x, negative 2 times 0 plus 3 squared plus 4. This gives us negative 2 times 3 squared plus 4. This then gives us negative 2 times 9 plus 4, which then gives us negative 18 plus 4, which equals negative 14. So f of 0 is equal to negative 14. Now this right here is a y-intercept. It's the value of y when x is 0. So when x is 0, y is negative 14. So this is where it's going to cross the y-axis. Okay? Now, it says here, when we find the value of f of negative 4, the value of x equaling negative 4, what does this result of negative 4 represent graphically? So this result of f of negative 4 represents the y value on the graph when x equals negative 4. Okay, so the graph of f of x is pictured to the right. You'll notice here the picture to the right. And do the results of f of negative 4 and f of negative 1 calculate above make sense in context of the graph? Explain why or why not. Okay, so if I were to look at the value at f of negative 4 and f of negative 1, we know that f of negative 4 equaled 2 and f of negative 1 equaled negative 4. So I'm going to check these values. If I were to write these as points, this point would be negative 4 comma 2, and this point here would represent negative 1 comma negative 4. So if I plot these, negative 4 comma negative 2 is right there, and negative 1 comma negative 4 is down here. And you'll notice that those points lie on that quadratic function. So this function would represent f of x. This right here is f of x. Okay, so when we say that f of -4 is equal to 2 and f of -1 equal to -4, meaning that those points that we just did should be on that graph, which they did. Okay. Now it says the graph of f of x has 2 zeros. Remember from algebra 3-4 or even math, previous math courses, what a zero of a function is and define the term below. Okay, so a zero is considered an x-intercept. Okay, so we're looking for any x-intercepts. Those are values of x, the value of x when y is 0. So we're looking here where it crosses the x-axis. So it crosses there and there. So those values are in between, our first x-intercept is in between -1 and -2, and -4 and -5. Okay? Now it says here, the graph of f of x clearly crosses the x-axis at a value in between -4 and -1. Based on your computations above, how could you justify the guarantee of this occurring at some value between -4 and -1? Well, if we look back up here, we know that the value at f of -4 equaled 2. And we knew that the value at f of -1 equaled -4. So we know that in order for us to have an x-intercept, the y value had to be 0. Well, it changed from positive to negative. You see that? When it changed from positive to negative, it had to have crossed at y equaling 0. Okay? So that's how we know that there's going to be a 0 there, because it had to have gone from 2 to -4. Okay? So, and you'll see the explanation in my notes that I wrote it out, that guarantees a 0 in between -4 and 1. I'm sorry, in between -4 and -1. Okay? So based on the graph, we cannot determine exactly what the zeros of the functions are. According to the graph, between what pairs of x values do the zeros of the function lie? So we've talked about that. We already stated that it had to be in between -1 and -2. That's right there. And it had to be in between -4 and -5. Okay? Let's go on to the next side where we have, I believe, our same function. Yep, that's our same function. On the previous page, we took the function of f of x and found values of y by substituting the x values. Now suppose we set the equation of f of x equaling to a, so some random value, and we solve for x. When you solve the equation for f of x equaling 0, what does the result of the x represent graphically and state the value of x? So what we would do is we'd have to set -2 times x plus 3 squared plus 4. And we'd have to set that equal to 0. Okay? Now, you could find those values by putting it into your calculator. Okay? You could find those values, or you could solve this. Okay? Which we will get to that later on in this lesson. Okay? So we know that the value, if we were to estimate this one right here, we could say it's approximately, this symbol right here means approximately, -4.5. And it's pretty close to -2, but it's not, like, it's a little bit over half of in between -1 and -2. So we'll say that this is -1.6. So those are our approximate values. Now it says when you solve the equation for -4, what do the results of x represent graphically and state those values? So if I were to set f of x equal to -4, I'm looking to see where on y equaling -4, at what points is that occurring? It's occurring at those 2 points. And those 2 points look like it's happening at -5, comma, -4, and the other point being -1, comma, -4, which we had done earlier. Okay, so those are the 2 values. We know that those x values would be -5 and -1. Okay. Now, let's actually calculate this by using some algebra. So we're going to do some algebra here to actually find it. We're going to take our function right here of what f of x represented. So we're going to take -2 times x plus 3 squared plus 4, and we're going to set it equal to 0. Okay. We're going to do the same thing over here, but we're going to set this one equal to -4. Okay, there we go. Now we have to solve for x. We have to get x by itself. So in order for that to happen, we have to get rid of this +4 first by subtracting 4. And we're going to rewrite what's on the left side without the 4. Okay, now the next step is we have to get rid of this -2 that's being multiplied. So we have to do the opposite of multiplying by -2. We're going to divide by -2. So this leaves us with x plus 3 squared is equal to -4 divided by -2 is +2. Now we have to get rid of the square. So we have to do the inverse of squaring something, or the opposite of squaring something, which is square rooting. We're going to square root. Okay? Now, whenever we square root both sides, this is a rule. Whenever we square root both sides, we always put a plus or minus. Okay, let's repeat that again. Whenever we square root both sides, we always put a plus or minus. Whenever we square root, we always put a plus or minus. Okay, so now that we've gotten rid of the square, we're going to do the opposite of adding 3. We're going to subtract 3. I'm going to put it in front. It's a cleaner look. You're less likely for this -3 to trail into the square root by putting it in the front. And this is our 2 answers. Okay, these 2 answers represent the exact values. These are called exact values. Once we use a calculator to solve these, we will then get decimals. So there are 2 answers here. The first answer is x equaling -3 plus the square root of 2. And then the other answer is x equaling -3 minus the square root of 2. And we could put those 2 answers in our calculator. So I'm going to pop up a calculator and I'm going to put those 2 to get our decimal answers. Those would be considered approximate answers. So I'm going to go to my calculator, pull it up here. Here's a calculator, and I'm going to just type in our first one, which was -3 plus the square root. Square root is blue button x squared. And then I'm going to put a 2 and press enter. And there's our first answer. So I'm going to write that one down. -1.585, round it to a 6. Now, whenever we write approximate answers, I would like it to 3 to 4 decimal places. No less than 3. Okay? So when you give me a decimal answer that has many decimal places, make sure it's 3 to 4 decimal places. So you could do -1.586 or -1.5857. Those are both acceptable answers. Okay, now we're going to find the other one. Now, instead of having to type this out, just to save a little bit of time, there's a little keystroke that we can do here. If we hit blue button, enter, it re-enters the line that we had previously done. Okay, then we can come over here and highlight the plus and change that to a minus, and then press enter. So then our other answer is -4.414. So these are approximate answers. They're pretty close to what the actual value is, but if we wanted exact values, that's these guys right here. Okay, but it's important to have decimal because then it allows us to see where on the graph is that value. You can't really tell on the graph what this value is until you put it as a decimal. We know that those values had to be in between, you know, the the -1 and -2 and -4 and -5. So there it is. Okay, so let's go back to our notes here and let's continue. So we've gotten our two answers here. They're right there. Those were our two x values. And those two x values were pretty close to what we had said. We had said that it was approximately -4.5. We got -4.414. And we got -1.6. That was our approximate. We got -1.586. So it's pretty close to what we were thinking. Okay? Now, we're going to do it when it's say equal to -4. So I'm going to do the same thing that I kind of did here, all the same steps, but this time it's set equal to -4. So I'm going to subtract 4 to both sides. This gives me -2 times x plus 3 squared is equal to -8. Now I'm going to do the opposite of multiply by -2. I'm going to divide by -2. This is going to then leave me with x plus 3 squared on the left. And -8 divided by -2 is +4. Then I'm going to do the opposite of squaring. I'm going to square root. And remember, whenever we square root both sides, we always put a plus or minus. So this is plus or minus. To save a step here, square root of 4 is 2. And then we're going to do the opposite of adding 3. We're going to subtract 3. And we have two answers here. We have one answer is x equaling -3 plus 2. And we have another answer of x equaling -3 minus 2. So our two answers are -1 and -5. -1 and -5 were our x values. If you notice, those are the same values that we had gotten in our graph. Okay? So in summary, when you evaluate f of a, what does the result represent graphically? Well, the result of f of a is the y value of the graph when x equals a. And then it says, in summary, when you solve the equation for f of x equaling a, what does the result represent graphically? The result of f of x equaling a is /r, the x value or values of the graph when y equals a. Okay. So that is the basis of function notation. Okay. Now let's just do, that's it. Oh, we got one more. Actually, one more question. Got this side here for our notes. Okay. So it says, for each of the following, use the given function to either function either the y value or given the x value, or the x value is given in the y value. Use the equation, but verify your algebraic results using the given graph. Okay, so it says find the value of g of -6. So here we have the graph of g, and they want us to find g of -6. So this is saying when x is -6, what is the y value? That's what it's asking. Okay, so we're gonna take g of -6. We're gonna plug a -6 wherever we see an x. So this is -6 plus 2 minus 5. And notice we have absolute value. So we have to do what's inside the absolute value bars, which is -4 minus 5. And the absolute value -4 is 4 minus 5. And so we know that g of -6 is equal to -1. Okay. Then it says find the value of g of 1. So we're going to go over here, g of 1. We're going to plug a 1 in for x. So we have the absolute value of 1 plus 2 minus 5. And this gives us g of 1 is equal to the absolute value of 3 minus 5, which comes out to 3 minus 5. So g of 1 is equal to -2. Okay, so you'll notice that those two values, if you look at g of -6 equals -1, that's -6 comma -1, and then this value here is 1 comma -2. Those values should be on this graph. Let's check. So -6, -1's right there. Good. And 1 comma -2 is right there. Good. It's on the graph. Okay. Next, it says, for what values of x does g of x equal -4? So if we were to look at the graph, pretty visually, you could see that if you draw a horizontal line, when the y value, let's say the y value is -4, what is the x value? That's what it's asking. What is x? Okay. So if you look at here, we can actually just find those values right away. We know those values are going to be -3 comma -4 and -1 comma -4. Okay. So that we know those values where they're going to be. But let's actually do the math. Okay. So how we're going to do this math is we're going to take our g of x, which is x plus the absolute value of x plus 2 minus 5. We're going to set it equal to -4. Now, the first step here is we have to get rid of the -5 by adding 5. So we have the absolute value of x plus 2 is equal to adding 5. That gives us +1. Now, whenever we have absolute value, it's very similar to a square root. We get rid of the absolute value bars, and we put a plus or minus 1. Okay, so there's two equations here now. We have x plus 1 equals 1, and we have x plus 1 equals -1. And then we're just going to solve. Let me see here. I got 5 plus 4 is 1. I got x plus 2. Oh, this should be a 2. These should be 2. So I was like, oh, that doesn't make sense. Okay, so I got x plus 2. There we go. Now I'm going to subtract 2 to both sides. So this is going to give me x equals -1. And if I subtract 2 to this side, this gives me x equaling -3. And you'll notice those are the two x values, just like we had done in our graph. Okay, now they want it for 5. So we're going to take x plus 2 is equal to 5. And we're going to move that -5 to the other side by adding 5. That gives us 10. Then we're going to get rid of the absolute value bars. We're going to put a plus or minus 10. So we have two equations. We have x plus 2 equals +10, and x plus 2 equals -10. And then we're going to solve for x. X equals 8, x equals -12. Those are our two answers. Okay, so if we were to look at this where x equals 5, this goes off the graph. And that's common to have questions where things aren't going to be on the graph, so you have to do the algebra to find it. Okay. Okay, one more. Here's our last one. So our last one here is they give us h, and they want us to find h of -1. So we know that x equals -1. They want us to find what is y. So we're going to plug a -1 wherever we see an x. And we're going to solve. So h of -1 is equal to -2 square root of 5 plus 3. Okay, so this is our answer here as an exact answer. We could put this in our calculator. So we could put this on the right side in our calculator, and it comes out to -1.472. Okay, so practice putting these complex numbers in your calculator. Now let's do h of 10. Plug a 10 wherever we see an x. So this is -2 square root of 10 plus 6 plus 3. This is going to give us -2 times the square root of 16 plus 3. Notice that this is a perfect square. So we know that the square root of 16 is 4 plus 3. So negative 2 times 4 is negative 8, plus 3 gives us h of 10 equaling negative 5. Okay, now this time they tell us what y is. Y is 1. We have to find x. Okay, so we're going to plug a 1 in for h of x. So we have negative 2 square root of x plus 6 plus 3 is equal to 1. Okay, I'm going to bring this up so we have some more space. So negative 2 square root of x plus 6 plus 3 equals 1. Okay, now I'm going to subtract 3 to both sides. So 1 minus 3 is negative 2. Then I'm going to get rid of that negative 2 that's being multiplied by dividing by negative 2. So I have the square root of x plus 6 is equal to positive 1. And I'm going to do the opposite of square rooting. I'm going to square this. Okay, squaring is different than square rooting. So we don't have to put plus or minus when we square it. So this gives us x plus 6 is equal to 1. Then we're going to subtract 6 to both sides. So we got x is equal to 1 minus 6 is negative 5. So there's our answer. Okay, and you could look, if we could plot this point, negative 5 comma 1, we could see if is that going to be a point that's on this square root function. So negative 5, 1 is right there. It's on it. So perfect. Good. Okay. Let's go to this next one here. We're going to take our function, last one for today, set it equal. We're going to subtract 3 to both sides. Divide by negative 2. Gives us positive 3, to the opposite of square rooting, squaring. Okay, there we go. We got 3 squares 9. Subtract 6 to both sides. And we got x is equal to 3. So x equals 3. And we could check that on our graph. We know the graph 3 comma negative 3. Let's see if that is on here. So here's 3 and negative 3 is located right there. Perfect. So that's how we could check using the graph. And that's it. That's how we compute involving function notation. Okay. So what you need to do, make sure you do your homework. Jot down any questions that you have from these notes. And I would love to answer your questions. And have a wonderful day. And Mr. Martin out. Bye.